Good day, folks. Welcome to Pride's Mind Academy, where we bring brilliance to every lesson. In today's video, we're going to be looking at organic reactions. I always liked this one. I don't know why. It's weird, but yeah, I know, right? So, okay, here I have the flow diagram below. This one I liked to now look at the diagram first, analyze the diagram before now being in a position of doing what? Of looking at the question. The flow diagram below shows how hexane, can you see? How hexane can be now converted into different organic compounds. Let us, which one is hexane? This one. Letters IV, blah, 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 represents different organic, what. So I want you to see here, what happens here. Can you see now we have C4H16, which is now an alkane. Okay, moving to what? Moving to an alkane again, plus something. So do you agree with me that reaction one, it is an elimination reaction? Because we are eliminating this one. Remember, we are cracking this one into smaller useful substances. So this one now, it is now cracking or elimination reaction. And elimination reaction for cracking, we need what? High pressure and temperature. High pressures and temperature. High pressure, high temperature. Remember, it's either it forms an alkane and an alkene or an alkene and hydrogen. But in this case, it is an alkane. This one, it is an alkane here. So it's going to form what? We have C3 here because 3, again 6 minus 3, it is 3 left. Then 14 minus 8, it is 6. So C3H6. This is an alkene. An alkane, right? Yes. Then this one I have now an alkane here. I have an alkane that moves to what? To 1-bromopropane. This is a haloalkane. So now from an alkane to a haloalkane, what is it? It is a substitution reaction, all right? A substitution reaction. What kind of substitution reaction? Hydrogenation. Not hydrogenation, sorry, halogenation. Halogenation. It is a substitution reaction. This halogen requires what? UV light. Or you can just say heat, but UV light, okay? Then from haloalkane, this one propane to primary alcohol. What is that? That is what we refer to as hydrolysis. Hydrolysis. It's either it occurs in the presence of water or sulfuric acid as a catalyst between the two. Okay? Yes. Then now, this is a primary alcohol also. Okay? Then this is what? This is alkene. Alkene, or this is a substitution reaction. Okay? This is a, actually, let me say reaction 1, reaction 2, reaction 3, reaction 4. This one, it is a substitution reaction. Reaction 1, it is an elimination reaction. Reaction 2 here, I am moving from an alkene, which is unsaturated, to an alkane, which is saturated. And remember, unsaturated to saturated, it is what? Addition. Why? Remember, single and still searching, I went to USA and found a beautiful lady called Sue. Okay? Yes. So yeah, moving from unsaturated hydrocarbon to saturated, it is addition reaction. But what kind of addition reaction? What is exactly my adding? Can you see now it is OH here? So they added water. Okay, so they added water here. So it is what? Hydration. I am hydrating. Hydration. And it needs what? This one, it needs H2SO4 as a catalyst. How interesting is that? And heat maybe. Can you see? Just knowing the reaction conditions thereof. Now, the type of reaction represented by the letters. Number one, I said it is what? Elimination. Or now accepted, you can say now cracking. Now you are showing us that you know your tabas, your news. Compound A, it is what? Addition reaction. We are adding what? Water from an alkene to a primary alcohol. We are adding water. It is what? Addition reaction. Or specifically what? Hydration. Right? Then for number 3, I am moving from alkane to haloalkane. This is what? It's just a substitution reaction. I substituted the halogen with a hydrogen, substitution reaction. Or now you can say it is what? It is me forming what? Hydrogenation. Halogenation, sorry. Halogenation. Number 4, it is what? It is what? It is also substitution. More specifically, it is what? Hydrolysis. How interesting and cool is that? Write down the two reaction conditions under reaction 1. Reaction 1, it is cracking. It occurs under high pressure. And also what? High temperatures. How interesting and good is that? Chemical formula for inorganic reactant in reaction 5. Reaction 5, here. Reaction 5, it is what? It is water. Remember, we are reacting, what is this? Haloalkane with water to form what? Alcohol. Okay? Yes. Wait a second, I want to see something. If I move from haloalkane to, or if I move from haloalkane to alkane, it requires an unreactive solvent. Yes. So this one will be what? Inorganic reactant. Remember, organic has carbon. Inorganic does not have carbon. It is what? H2O. How interesting and nice is that? Balanced chemical reaction for complete combustion of hexane using molecular formula. Molecular formula is C4 and all of that. So let's try to do that. C4H14. We have what? C4. Okay, let's do it here. C4H14. Remember, it needs to react with excess oxygen to form carbon dioxide plus what? Plus water. I'm leaving space so that I can balance. How many carbon do I have? 4 in that side. I need 4 on also this side. Hydrogens, how many do I have? I have 14. On this side, I have 7. Can you see? So I have 2. I need 7 so that it can be 14. Then how many oxygen do I have? 4 times 2, it is 8. 8 plus 7, it is what? 15. So I need 15 divided by 2 here. Because when I say 15 divided by 2, it is 15 divided by 2. But now remember, I need to multiply out this one by how much? By 2. Because remember, I do not want my balanced equation to have what? To have fraction or decimal. So it's going to be what? 2C4H14 plus, when I multiply this by 2, it's going to just be 15O2, forming me what? 4 multiplied by 2, 8CO2 plus 7 multiplied by 2, it is 14H2O. I'm done. How interesting and nice is that? Can you see? Is it balanced? 8 carbons, 8 carbons. 28 hydrogens. 2 multiplied by 14, also here 28 carbons. 14 plus 16, it is 30 carbons. So oxygens, here 30 oxygens. Now the first mark, it is you writing C4. Not C4, I'm sorry. Not C4, C6. C6 here, right? C6, you writing the reactant and the product. C6 and H14 plus O2, 1 mark. Writing CO2 plus H2O on this side, 1 mark. Whether it is balanced or not, 1 mark. Okay? Then the other mark, it is if it is balanced. IUPAC name of primary alcohol B formed during reaction 2 and 5. Here, they want to know the type of alcohol formed. So here we have 1-bromopropane, the type of alcohol. IUPAC name of alcohol or IUPAC name of it. Nah, man, it will be just, remember we are removing BR from position number 1. We are substituting it with what? With OH. So it means this one is going to be 1. Sorry, this one is going to be propan 1 all. Why? Because we are substituting. Let me throw this. People will say, nah, I'm just tweaking. Propane, it is 3. And we are told on carbon number 1, we have OH, right? Remember, in a substitution reaction thereof, we are going to substitute what? This OH with what? With manaskis. This is BR. And it reacts with what? With water. Water, it is OH and H. Okay? So what will happen? We will substitute this BR with this OH. Then it's going to form us something like CCC, blah, 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 OH. So can you see? The position did not change. It's still 1. So it's going to be 1-bromopropane. And they are telling you it is primary alcohol. So it is not 1-bromopropane, man, sorry. Propan 1 all. Propan 1 all. Propan 1 all. Structural formula of compound A. Where is compound A? Here is compound A. So now if this is propan 1 all, and this they added H2O to it, so we work in reverse. We know here we have what? Double bond, how many? 3. Okay, we have 3, but you do not know where the double bond is, right? We check, okay, where did they add now water? They added water to this one, okay? So it means they added water. One of the water that was added, okay, let me see. They added water, OH and H, okay? So where did they add water? The OH that they added first, it is here. Then the H that they added should be on the next carbon. On the next carbon here. So this is what they added. So it means now we had a double bond here on carbon number 1. So it means on carbon number 1, we had a double bond like that. So this is what we are supposed to draw as our structure. As our structure thereof. How interesting is that? So now I can take this and say, this is the structure that we are in a position of drawing. Okay. Yeah. This is the structure you are in a position of drawing, and come and say, why does it not want to move? Sure, it's fine. I know that it is what? It is 1. It is propan 2 ine. I hear propan 2 ine. So when I draw that, it's gonna be propan 2 ine, something like propan 1 ine. So 1 in, propan 1 in, because the functional group it is on carbon number 1. When I need to draw, I need to include all the hydrogens needed. I'm done. Primary alcohol B reacts now with what? With methanoic acid. Define what is a primary alcohol. A primary alcohol, now we say now it is a what? A carbon bonded to the hydroxyl group. Is bonded to one other carbon atom. How interesting is that? Identify the type of reaction. Remember, when I'm reacting alcohol with carboxylic acid, I'm forming what? Esterification, an ester. So this is the esterification. cation reaction. Write down the name or formula of a catalyst used. Remember, it should be what? A concentrated H2SO4. But they wanted the name or formula. The name, it is sulfuric acid. Use structural formula now to write a balanced reaction for the above reaction. So now I'm reacting what? I'm reacting what? Primary alcohol B. Primary alcohol B, it is what? It is this one, propanol. I come and say, where is propanol? Propanol, I draw it like this. Propanol, I want you to look me this carefully. Propan 1 all. Like that, right? This is my propanol. And it is reacting with what? It is reacting with what in that particular case? Methanoic acid. It has one carbon. So it reacts with methanoic acid. OH. Like that. So it is just reacting with methanoic acid. I want to put it like here. Like this. I want you to see what will happen during the reaction, the off. Let me put it here. Okay. Right? Now, when I form an ester, I know I need to form a water. But now that water, I take it from where? I take the OH from the what? From the carboxylic acid. And I take an H from the what? From the alcohol. Then what? Whatever that I see, the remainder, I just draw them as they are. What do I mean by that? I mean that, can you see I'm left with this? H, H, C, H, H, C, H, H, O, again. Then I continue. Then after moving to O, I move directly to what? From O, I move directly to C. It's going to be C double bond O H, like that. And they wanted the what? Structural formula. So I'm going to say plus. After removing these two, I want to show you something. After removing these two, the off, you just combine these. I mean, you just combine these. So, you just combine these like that. Okay, remove this also. This is what we have there. I guess this is the hydrogen. Can you see? This is exactly what we have there. Okay, but let's reverse that. Plus OH. They won't penalize you if you say O2, it's fine. First mark now, it is you drawing what? It is you drawing this, okay? As well as this and this functional group. Functional group, this one, it is correct. Okay, yes. Then the last mark. How easy 5 marks is that? So that's all from me on this video. Let's meet on the next one. Thank you.